So really quickly, before we get into these things, I'm just going to do a really quick introduction so you know that I'm like working with React and I'm like qualified to like tell you about these things. My name's Heather. I'm a full stack developer at Nascent Digital. I've been a developer for about 6 years. Before my experience in Nascent, which I've been there for about 2, I was a front-end developer at like various different agencies here. If you want to find me online, if you want to just say hi, or again, you have questions about the deck, these are the 2 places you can find me. My portfolio has like all of my other social media handles. Unfortunately, I'm not popular enough to get the same one everywhere, which is why I only shared my Twitter. I wish I was cool enough, but honestly, I'm not quite cool yet. We'll get there. So the first thing I want to talk about, which before we get into these cool features, I want to talk about function components, which React used to call, or like we as a community used to call, stateless functional components. But with the addition of these new features in React 16, React is sort of moving away from that naming because state exists in function components now. So the reason I want to talk about that is because I've sort of geared these 3 features that we're talking about around that. At least 2 of them, so hooks and React Memo, exclusively work with function components, but Context API also gives us a better reason to use them. And now why is that important? Why do I think that's an important thing to share? Because general opinion, but also personal, function components are better than class components. There's reasons for this, though. You can Google it online. You can see people who are much more smarter than me talk about it. But function components are easier to understand from a human perspective, but also from a computer perspective. They have less code, almost always, but especially when you have to transpile your code down into ES5 for all of those IE11 users, classes take up way more code file. And then also, a function component is naturally easier to test. It's a little bit more scoped, there's less work involved with it. So with the addition of these features coming into React 16, we have more of a reason as developers to start using function components, because now, I don't know about you, but I used to code a function component, and then as soon as I needed state or a lifecycle method or literally anything that wasn't a simple function, I'd have to switch over to a class component. And so these ideas, especially the hooks, but also React Memo, start making that less often. We can actually use function components more and kind of move away from the class component setup. So we're going to start with hooks, like I mentioned. It's the coolest one. It's also the hardest one. Bear with me if you get lost. I'm going to reiterate myself a lot with the intention of sort of trying to nail down the key concepts. And then if you have questions at the end, again, feel free to ask me. So the main thing to know about hooks, because a lot of people are generally really worried when updating React versions that they're going to break their entire application. Hooks doesn't have any breaking changes. You can update to a React version with hooks and not change your existing code base. React actually recommends to start using hooks, don't refactor your entire code base. That is not the best way to understand hooks. That's not the best way to see if it's the right for you and your code base. Hooks are meant for not even meant for, really the best way to start with hooks, to see like how you use hooks, how you can extend hooks, all that value. As you're creating new components in your code base, use hooks, if you can. Like, see how they work, see what their values are for you, see how they work with your existing team. This is just another feature with React that your team and your code base can use to make it better. So you don't have to like change your entire roadmap and like work with your like POs and all that stuff to like get 6 weeks to change every class component into a function component. Hooks don't bring breaking changes. There's also 3 types of hooks. 2 of them React extends for us, and then also we get a custom hook support. So the 2 that we're going to spend a lot of time on are useState, which is in the name, replacement for this.state, this.setState. useEffect, which for all intents and purposes functions like the lifecycle methods, and then we'll also be able to extend those with custom hooks. So really quickly, I wanted to just give us all a refresher. I know we've all probably, for the most part, spent the day coding, but a quick refresher of what a really simple class component looks like in React, right? And how we use state. So obviously, we've got our constructor. We're setting our initial state object with a value count. And then in our render function here, we've got a really simple paragraph tag. We're just going to render out that state 0. And then on the button, obviously, we get a cool function, this.setState, which updates our count. This is super straightforward. That exact class component in a function component looks like this. So going through this, we'll sort of go through this line by line, but really, obviously, line 4 is the bread and butter of a useState function. So similar to how you would import a component or anything in React, it comes into the top of your file, importing useState like that. Then we get into our function prop, like our function component. This one is like a standard ES5 function, but again, if you use arrow functions, like whatever you want to do this, we're just rendering a function. Then we get into line 4 here, and let's spend some time here. Let's really like dig into this. So useState accepts one argument, always. It will never accept another argument, and it's only the one argument, and what that argument is the initial value. So going back to our class component for a second, when we set up our initial value here, we give count a value of 0. So in the same breath, when you use state and you want to set an initial value to 0, you pass it through the function as an argument. Then we get into the left-hand side, and we've got count and set count. And the reason why the left-hand side of this like variable call looks like that is because use state always returns 2 items. It returns the state data type, so just how you would do like this.state.count, it will always return that for you, and it always returns a function that will let you update that data type. It doesn't matter what you call these. These can be called anything you want. There's no naming parameter to them. The order is what matters. So when you use state, in your array, the first one is always going to be your state storage. Again, doesn't matter what you call it. This could be like, you'll see examples like fruit, age, et cetera, et cetera. It can be whatever. And then it's your function. So state type, then function. And they're just using like a fancy array destructuring for this to keep it on one line. Technically, you could do this in a much more like verbose way, but this is the simplest way to use state and then have access within your function component to the state itself and the function to edit it. Then we get into our return here. And again, this is really straightforward, but it's just to show you exactly like the class component. If you want to render the count, you just put it in curly brackets. But then the difference here is if you want to change that, instead of a function like this.setState, because obviously this doesn't exist in a function component, there's no scope, you use setCount directly, and you pass it an argument. And setCount will always take whatever value you pass it and essentially dump it into the count state. So the value here, the thing you really want to pay attention to is that useState tightly couples your item and the function to change it. They're moving away from this idea of one object being your entire state storage, and then this.setState. It's just one pairing of value and function. But obviously, we all have complex code bases, and one pairing is not enough for many of us. So you just use as many use states as you want. The value of a function component, because for all intents and purposes, it is just a JavaScript function, is we're just setting variables. It looks fancy and it looks a little bit confusing, but we're just setting a variable of age, set fruit, to-dos, and set to-dos. You're just using React's use state to pass existing function or existing logic into those. So 2 things you pass in. Obviously, the order matters, and you always pass in the initial argument. In our count, we were passing in a number because we were just updating an integer. You can see in these 3 examples, you don't have to pass a number into use state. It can be whatever you want. So it can be a number that you change, so age, obviously, strings, arrays, objects, whatever data type exists in JavaScript, dump it in there. The world's your oyster. You can put what you want. Other thing to acknowledge here, React guarantees the order that things are called in. Because JavaScript is run line by line, the first use state will always run before the second use state. You are never going to have an issue where 6 lines down, a use state gets triggered before the first one. It always runs, so you can trust the order of the functions you're calling. Okay, so that's use state, which essentially, obviously, brings the coolest part of class components into function components, but almost equally as cool, I think a little bit less cool, but that's a personal opinion, is lifecycle methods. So again, let's do a quick refresher. Class component, we've got 2 lifecycle methods here. I would have showed all of them, but a slide deck is not big enough. We've got our 2 standards, component did mount, component did update. I would say that like 9 times out of 10, these are the 2 that we always want to use. They're best practices. Obviously, React is making some of the more easily abused ones unsafe, but these 2 are sort of like the path moving forward, right? We've also got component will unmount and component, et cetera, but we'll talk about those. So this is what a standard class component looks like with lifecycle methods. And right away, I think, obviously this is a very simple example, but we can see that we have to duplicate some code in here, right? So class components have a lot of power, but useEffect is actually going to start helping with some of the things that class components can't do for us, namely coupling our feature code. So just like useState couples its value and function pair, useEffect tries to couple all of your feature code. Because I don't know about you, but I've worked in some pretty large applications where among 5 different lifecycle methods and different functions inside of it, one feature exists. And that can be problematic when you're a new developer trying to come into that code base, you're trying to understand what the tests are trying to do. When your component becomes hundreds of lines long and the 6 features are within 6 different lifecycle methods, it's really difficult to parse that as a human. And so useEffect fixes that. Again, just like our useState, this function component is the exact same example as our class component. The joy is that we only call useEffect once, and it runs every time. So let's dig into that a little bit. In useEffect, the first argument, it's really just a function you call, and the first argument you pass into it is a function itself. So standard practice I've been seeing is arrow functions pass through this, but theoretically you could pass like a function via name, you could pass a standard function, whatever works best for you. But this seems to be what the general method of calling useEffect looks like. Inside of this, we've got our document title, just like we did in our component did mount and our component did update. The value of useEffect, and really sort of how you can think about it is essentially lifecycle methods for function components, and that's a really easy way to start thinking about how to use this, but React is kind of moving towards a after render methodology. So React it mounts your component the first time, useEffect runs. React updates your component via props, whatever, useEffect runs again. useEffect, essentially, every time React re-renders your component, it will re-render with useEffect afterwards. So that's kind of how they're in for it. So you can think of that, useEffect happens after a render. And that's awesome, because component did mount, component did update, those are asynchronous, right? They happen after render. We're not going to talk about it today, but I really quickly wanted to acknowledge that there are some use cases where you want a synchronous call. You want to kind of like block your render, or you want to like be based off of layout. And so React offers another hook called useLayoutEffect. It is, for all intents and purposes, useEffect, except that it happens synchronously. So we're not going to talk about it, because in your brain, if you want, you can replace all the times I say useEffect with useLayoutEffect. So here's a really quick visual guide. I did not make this. Credit entirely goes to this username's account on GitHub. And this visual is a class component. It's not a function component, but I thought it was a really great way to visualize how useEffect runs. Essentially, like I've mentioned 6,000 times now, component did mount and component did update, useEffect will run every time, essentially after a render. useEffect also runs as component will unmount. So getting into that, this is what useEffect looks like when it wants to component will unmount, essentially. You'll notice, first thing, obviously, I've given us a more complex useEffect for an example here, because I couldn't think of a way to show a cleanup of function that was about document.title. So in this example, we're using a useState because why not? It's fun. And essentially what we're doing is creating this like arbitrary chat API, and every time the component mounts or updates or essentially renders, we want to subscribe that API to the friend that's online, like the friend ID of 1 and whether or not they're online. That's what we care about. But when that component unmounts, we actually want to update that API and say, hey, I know you've been listening to this friend, but like we don't care about them anymore. Really quickly, just like clean up your system. Component will unmount is obviously the ideal place to do that, and so useEffect wants to give us that. Every time you return a function in useEffect, in this instance, I'm calling it function cleanup to be very explicit, but again, you could return an arrow function, you can call this whatever you want. Anytime you return a function at all, it is treated like component will unmount. This return function will not run on mount or after render. It only runs as a component will unmount. There's a bit of a caveat there, though, because like I mentioned earlier, useEffect is sort of like an after render function. It's not quite like lifecycle methods. What I mean by that, essentially, in this case, is that React is sort of treating like a pre-update as if the component was going to unmount. So imagine the use case, the component mounts, and we've got the friend ID of 1, and they're online. So we update the subscriber status with that. But the component's going to update, and we've got friend ID 2. And in this use case, we don't care about friend ID 1 as soon as we get a different friend ID. Well, there's no point in that API continuing to subscribe to friend ID 1. And so in old class components, we would have to actually run a subscribe to status and an unsubscribe to status up here and essentially start conditionalizing it, whether or not it had previously subscribed. React fixes that. Before it's going to run an update, if there is a function returned, it will run that cleanup code and then run the rest of the remaining code. So it sort of starts, instead of at the top, it'll start here if it exists, and then loop back. So that's really great. And that's also really valuable. I would say there's probably not a crazy use case for that all the time, but it's valuable when you need it, and it's great that they've offered it in case you need it. But now there's another lifecycle method, and I've personally used this one, so I'm assuming other people have as well. Should component update? Obviously, sometimes we want to prevent a component from rendering unnecessarily. Sometimes there's a lot of props involved and it's causing a lot of performance hits, and so should component update comes into play there. Well, useEffects got our back again. The first argument in useEffect, like we've seen, is always a function, but they actually support a second argument. That second argument is an array, and you can pass it props and state. By passing that value, just like should component update, useEffect will do a shallow render comparison of that prop. So in this case, props friend ID, because it's really the only one we care about in this case. If that doesn't change from friend ID 1, we don't run any of the code. If it does change to friend ID 2, we really quickly run that unsubscribe from 1, and then we subscribe to 2. So we keep it optimized in that regard. Now, awesome, it's still a hook. So just like useState, you can call as many as you want. The order matters. You can call it in whatever order you want and trust that it will exist. And the value of keeping multiple useEffects and separating it like this is because it keeps your code, feature code, tightly coupled. You can have one useEffect for your document title, and you can conditionalize it based off props as much as you need. You can have it run every time. You can have another useEffect for this really fancy subscribe to status one, which would have its own conditionals. This makes testing easier. This makes it, from a human perspective, easier to understand. If you have a component with 6 API calls and different lifecycle methods, you can have 6 different useEffects, right? So that's really valuable, and this is the pattern that React is recommending moving forward. Okay, custom hooks. These are different than the first two. They're actually more of a convention, not a feature. You don't import a special thing from React to get a custom hook. There's really only 2 rules to having a custom hook. The function name must start with use, and it has to call other hooks, so useState or useEffect. Now, it seems kind of silly that the function name has to start with use. By no means would this break React, but it's a pattern that they're recommending, and it's a best practice. One of the main reasons is because React supports like a hook linter you can import into your library in your application, and it doesn't know how to lint a custom hook. It doesn't know it's a custom hook if it doesn't start with use, because looking at this code, a custom hook is really just a JavaScript function. There's nothing unique about it. It just calls other hooks inside of it. So in this case, we've got a custom hook that's using state, and it's using our effect. It's actually the exact same code we saw like 2 examples back. The difference, though, is that we've decided to return is online with this custom hook. Not because that's what custom hooks need to do, but because that's really all we care about based on these 2 hooks themselves. So if we look at our component up on the right-hand side here, this is an actual component that ideally would normally have had all this code in it, but we actually want to have 2 components that update the API based on friend status. So we just import the custom hook, use friend status, and we just set it to a variable. So on line 2 there, we just say, hey, check and see if this friend is online, pass it the ID. It does all of this fancy code and just tells us. So we've simplified our component logic so we can make, again, testing easier. The important thing to talk about custom hooks, they do not share state. So just because we use state in here, just because we use effect, doesn't mean that if you import this into 6 different components, they're all using the exact same data. Every time you import a custom hook, you can treat it as a new instance. So it's not solving Redux. We're going to get into the context API in a second, which is like an alternative to that. Custom hooks, that is not their intention. It is truly just to reduce code duplication, to make your testing easier, to black box some things. It's not an actual feature, it's a pattern. those are the 3 hooks. 2 last rules. I didn't make these rules up. These are rules from React. So they have to be top level only. And what I mean by that is you can't have a conditional in your component that decides whether or not to set state. You don't have a conditional in your component that decides whether to loop through a use effect. And the reason for that is React is guaranteeing us that the order you call your hooks in will always be the same. As soon as you put them in nested functions, into loops, conditionals, et cetera, React can't guarantee that anymore. And so now there can be unintended side effects because you might be relying on certain things that don't exist in those capacities. So it has to be top level. Hooks also have to be used mainly in function components, but you're also allowed to use them in custom hooks. They won't work in class components, so don't use them. Okay, that's hooks. That's the hardest feature we're going to talk about tonight. If you have questions, again, ask me at the end. Quick summary over that. 2 main ones, use state and use effect, and you also have a convention of custom hooks. The main value, aside from the fact that they make function components awesome and we can use them more often, is that they keep your feature code tightly coupled together. I've said that like 12 times, but it's super awesome that they do that. If you want to, I would recommend trying out hooks. Honestly, the best way you're going to figure them out is just like try them in a new component, see how they work, et cetera, et cetera. But if you want to do some more reading about hooks before you start playing around with them, React has great documentation on this. They've really spent a lot of time giving you examples. Honestly, all of the code examples I just showed you are from React's documentation. So they have great documentation. I also recommend their FAQ on these. They ask really great like layman's questions on these, and they actually helped answer a lot of questions I had. So super recommend those. Context API. Sharing is caring, friends. So Context API is React's way of in library, essentially, like supporting the absence of prop drilling. I'm sure a lot of you know what prop drilling means, but so that we're all on the same page, prop drilling, when I say that, what I mean is a parent component sets its local state, and then it passes that state to a child component, which passes that state to a child component, which passes that state to a child, and then we go down and down and down. And it's terrible for reuse because, again, 6 months on the road, a new developer comes in and is like, where does this prop come from? And like, how do I change this bug? And like, what exists in the world? So Context API is another solution for that, just one. It is not the be-all, end-all solution. I would love if it was. I don't think we're going to have one quite yet. I would say that it sits somewhere in the middle of a component keeping its own local state and a library like Redux. Obviously, Redux has a lot of value. There's other libraries. This is just one example. But Context API sort of sits in that really interesting middle space where like maybe you need like some like theme information shared between components, or like something that like is shared between multiple but like doesn't require a whole external library, that sort of thing. It's also important to know it can make reuse difficult. A big portion of this is how you code your contexts, but certainly anytime you're sharing data in between components that lives in a third space, understanding where that comes from can be difficult. So that's important to value. There are 3 steps to a Context API, and the provider is probably the hardest one. Create new context essentially is just your way of saying, hey React, I care about having this thing. Use provider, that's how you, essentially where you're going to store your data, where you'll update your data. It's going to be the thing that like owns all the data stuff. And then use consumer is what components will call to say, hey, give me that data. Creating context is super easy, like crazy. Probably the easiest thing in the world. React.createContext. There you go, you got context. All you have to do is set this to a variable. So in this example, we're calling it myContext. And React.createContext essentially initializes that variable with a provider and a consumer already. We're going to extend those 2 things, obviously because it's valuable, but just by writing createContext, you can start using this. You can also do this wherever you like, honestly. I've seen some examples where, like, for large-scale applications, people will create like a context folder, and then they keep as much of their context code in there. Some people do it on like their app level for smaller components and applications. Wherever it works for you, that's where you do it. And again, this is a theme, as many as you like. You could have a theme context, you could have a color context, you could have a cat's context. Whatever you need a context for, just like generate new ones. They are totally separate and like not related at all. So you can do as many as you want. Okay, so then we get into the provider. This code on the left-hand side here shows two items. One, it shows the provider that we're going to code, and then two, it shows how we would consume that provider. So let's ignore all of the juicy stuff in the middle there, but all a provider is really is a function component, right? And it's going to return some stuff. But when you want to use that provider, all you have to do is import it into a component and then just wrap wherever you want to use your consumer, wrap it around that. So in this example, because it's a very simple one, we can imagine that like our app, we just want our whole app to have the theme context. So we just wrap my provider around props.children, and then this gives us the flexibility. No matter where in our children tree we are, we can import a consumer and it will have access to that data, which we'll get into that in a second. Getting into the juicy part of a provider. There's two items we care about here. There's the value prop on myContext.provider, and then the render props that we return, right? So that's pretty much the pattern of a provider. In this case, we're just using some local state that we're going to share among all our components. But again, you could, if you needed to use use effect, you could do like API calls in here. Really, whatever data you need to share, you can make in this provider. And then myContext.provider, it's important to know that's just this guy. We initialized myContext, and it already has instances of provider and consumer. So all you have to do in your provider function component is return myContext.provider. And then the value prop that we're passing here, it's an object. So this starts to feel a lot closer to what like this .state looks like. Value is an object. And in this case, we're doing a one-to-one and saying, I want to be able to access the age object, like age value, and I want to be able to change that value. You could make this whatever you want. Just like how you would use this .state, that's what you can do there. So then we get into our consumer. Const example, this is just a standard component. It doesn't actually, it's not like a specific consumer component. It could be like whatever component needs that data. In this case, we're returning like myContext consumer wrapped around the entirety of the JSX, but you could import, like you could return like other JSX with the consumer partway through it. Like again, as long as it's just myContext.consumer, and then everything rendered inside of that open and close bracket has access to the data. You don't have to return it top level of your component. It's really like whatever you look like. The only two things I think, if I could really nail it in, the things you have to take away. myContextProvider has to render props, like wrap around props.children, and the value prop. Those are the two things that really matter. And then myContext.consumer always returns a function child. And that's because, you'll see there, we've got our little context guy in the open brackets. You could call this whatever, but we call it context. I called it context. It has to return a function, and then it's just JSX inside of that, because that function is actually what gives us the ability to use that value prop. And so context in this consumer is a one-to-one relationship with value. So you'll see if we go back again, our value is just an object with age and set age. Well, in our context, we can just render out age, and we can call set age if we want. So that's really the structure of a context, how you use a provider, how you use a consumer. These are very simple examples, and they certainly don't show all of the varying ways that you can like embed consumers and providers in your components. But for the most part, these are just like standard components you can import and render wherever you need to. The important part, again, is just that a consumer has to be a child component of your provider. If the consumer is rendered outside of a provider, it has no idea what context is. So looking at our app, we're just rendering all our children within that provider. Consumer has to be a child. It does not have to be a direct child. So in our app, we could wrap everything in my provider. We could have like a template component, which then renders a header component, which then renders like a title component, which then calls our example component, which calls the consumer. That consumer will have access to the provider value. Last thing, this is all the code, by the way. It fits on one slide. I was so impressed. The last thing to know, React forces a re-render for consumers every time the value prop updates. You can't kill it with a should component update. You can't prevent that render. The reason for it is so that React can guarantee that all of your consumers are sharing the same data. That being said, React's not a monster, so any component rendered inside my provider that isn't a consumer won't also re-render. It's just anywhere a consumer exists that's going to trigger a re-render. That's Context API. So, like I mentioned before, it's an option. I think it's a great option, especially for like mid-level applications. And I think it's a good thing to learn to have in your toolbox. It's not going to solve all your problems, but knowing when it can be pulled out is valuable. I think Westboss has a great, like, it's a 15-minute video tutorial on this thing. It really, like, in a very simple way, walks you through Context API, and then I think it's more than enough for you to get started playing around with it on your own. We're doing React Memo now, friends. This is the smallest one. It's going to be like 0.2 seconds, and then I can answer all your fancy questions. So, like maybe a quick show of hands or like whatever. Who here's heard of pure component? Okay, great. So I'm using this reference, but I was like, okay, I don't want to be like that person who like references something that nobody knows. So React Memo is essentially React pure component for function components, and I'm going to show you an example of both of those. If you don't know what pure component is, don't worry, we're going to ignore that almost immediately. The value of React Memo is it's a performance optimization. So it's super simple to use because you don't really have to extend it. You don't have to do a lot. It helps your function components be smarter, essentially. It's important to know it's not a render preventer. It doesn't prevent a render. However you say that the opposite way. You should not use it to prevent a render because it's not, that could prevent bugs, basically. That could introduce bugs, so it's just a performance optimization. It's just a way to say, hey, React, if you don't have to, I'd love if you just like showed me the cache version of this. Like, don't tell React to not render. The reason it's called Memo is because it works by memoizing the component. I'm sure there are very smart people in this room. I had to Google that word like 12 times before I could actually remember it. So I included a screenshot of Wikipedia's definition so that I could remember what it meant. Essentially, it's the really fancy way of saying it caches the component. So every time it renders, it's going to cache that, and then it's going to check, did any props update? And if they didn't, it just returns you the cache free of charge. Okay, so this is the code. This is what a pure component looks like. So React pure component, just like you would extend React.component, you can just extend React.pureComponent. It's a performance optimization. That one's a freebie if you want to learn about it. React Memo is the same way. So in our function component, normally, imagine that this like doesn't exist. We would just do my component equals props arrow into the function. You want to have a fancy performance boost, just wrap it in React Memo. And that's it, like end of story. This is like the last slide, basically. So that's really great because essentially like sort of how you would start with a function component and then upgrade to a class component when you need to, I recommend doing something like that with these as well. So start by wrapping your component in React Memo, and then if you need it to render more often than it's doing, just get rid of it, right? So by default, you can have a performance boost and then take it away if you need something else. React is, if not supportive though, and so they allow us to pass it a specific function to be more specific about whether or not we want it to update. By default, React Memo does a shallow comparison of its props, but you can actually pass it a function as its second argument and compare your props and your next props, right? It essentially, for all intents and purposes, is should component update. The caveat is that, I'm not going to read all of this, but it essentially returns true. So when you do should component update, obviously you want to return false. You're like, hey, did nothing change? Return false, right? React Memo is the opposite. They're moving away from that. So you're saying like, hey, did anything update? Yes, so return true. Otherwise, you return false. So a quick summary of those two slides. It's an easy way to get a performance boost. It's essentially caching, but with a really fancy term. And React's documentation is honestly like 3 paragraphs. So I super recommend taking a look at that if you want to learn more. But you could even just get started with it and see how your React components update. Thanks, friends. That's it. I'm going to just immediately open it up. Does anybody have any questions or like thoughts, opinions, concerns? Yeah, what's up? Is it good practice to have nested contexts? I guess it depends on what you mean by nested contexts. So if you mean by like having nested consumers, probably within reason, honestly. If you're going to have a consumer and then 3 components later have another consumer and then 3 components inside have another consumer, you're probably getting pretty deep. And I would actually take a look back and see like, what is your code structure looking like that would like require you to have the same consumer imported in 3 different nested components. Yeah. Anything else? It's okay if you don't. Okay, what's up? Yeah, so use effect, all of the hooks, to be honest with you, don't work in class components. Class components, by the way, as much as I kind of like ragged on them at the very beginning of this, they're not going anywhere. React has no intention of like moving us away from them anytime soon. The value of these hooks, especially use effect, is that right, like before these, function components were really dumb, and that was a good thing, and it is still really a good thing. But you had to essentially include an entire class if you wanted even one lifecycle method, and so use effect is a way to start bringing that into function components. Yeah. What's up? So, to reiterate, how does Memoize different from suspense, and are they going to move towards one versus the other? That's a great question. And I have no idea. Honestly, it's one of the values of React is that there's so many features coming out all of the time that I think it's a challenge to stay up on everything. So I've been using React Memo. It's been on my like to-do list to learn suspense though. So if you've learned suspense, welcome to share with everybody after if you want. What's up? Is it easy to wire up the hooks with something like Redux? Absolutely. And if you look online, there is a whole army of people who are starting to create hooks for like use Redux, use reducers, et cetera, et cetera. I would be like, wouldn't be shocked if in like a couple weeks Redux came out with like a thing you could just import. Yeah. Anything else? Yeah, what's up? Mm-hmm. Mm-hmm. Right. So to reiterate, just so I can make sure I'm answering the right question, how do I have a distinction between using a function component versus a class component? Yeah, I mean, like, my general perspective on that is always start with a function component, and then if you need a class component, upgrade, right? So that's a personal opinion. That is by no means like a standard. I'm sure if you talk to like 6 different developers or like 6 different companies, some people always use classes for their like parent level components, and like, do you know what I mean? Like, there's always practices and patterns. I think it's what works best for you, honestly. And so I think for me, and one of the cool things of the value of this is that React has started releasing features just for function components. And I think that's really important because they've essentially acknowledged, and like even in like their documentation, they've acknowledged that function components are offering something that class components can't offer. And they're just trying to bring them up to a standard that class components also support. So you have a bit more flexibility to choose, okay, in my application, what makes the most sense? Yeah. Does that answer your question? Yeah? What's up? Mm-hmm. Mm-hmm. Right. So to reiterate the question, how would I use multiple contexts in the same component? It's possible. It is a little weird, honestly. If you look at React's documentation, they certainly have examples of how you could use multiple contexts. The big important thing that you have to be aware of when you're using multiple contexts is that like what value is my consumer importing. But the cool thing, and so I'm not going to go back because it's like 1,000 slides deep. So we created a context under a variable, right? So my context has its own provider and consumer. You can reference that consumer using my context, right? So if you have a theme context, it's like theme context.consumer. And even if that component has 2 providers above it, you're telling it specifically what provider do I care about. So it's definitely possible. I think the challenge that you have to face is how do I keep my code like clean and understandable? React totally lets you do it. It has no issues extending that. It's just like from a best practice. How do you do it, right? And I unfortunately have not answered that yet. Any other questions? Okay, cool. Thanks, everybody.